Good day, everyone. I'm Kent Andrew Betty Saturinas from BSCPE 2A, Group 8. Today, I'll be presenting a report about solar cells under ICPE for energy conversion. In this report, I'll explain what solar cells are, how they work, their different types, and where they're used. A solar cell or photovoltaic cell converts sunlight directly into electrical energy using the photovoltaic effect. It's mostly made of silicon, either monocrystalline or polycrystalline, with a p-n junction that separates positive and negative charges when light hits the surface. Many cells are combined to form solar panels that can power homes, buildings, and industries. Since they have no moving parts, solar cells are silent, durable, and environmentally friendly. The principle of solar cells is based on the photovoltaic effect. When sunlight hits the surface of the solar cell, photons transfer their energy to the electrons in the semiconductor. These electrons become excited and move freely, creating what we call charge carriers. The p-n junction inside the cell pushes these charges to opposite sides, generating a flow of electric current. This direct current, or DC, can be stored in batteries or converted to alternating current, or AC, which is what we use in homes and industries. There are four main types of solar cells. Monocrystalline solar cells are made from a single pure silicon crystal. They're very efficient but also more expensive, often used in rooftops. Polycrystalline cells are made from many silicon crystals, making them more affordable but slightly less efficient, and they're more common in large solar farms. Thin film solar cells are flexible and lightweight, though less efficient, are used in portable devices or integrated into buildings. Lastly, emerging technologies like perovskite and multi-junction cells aim to increase efficiency while lowering production costs. Solar cells are used in many ways. For residential and commercial use, they're installed on rooftops or even integrated into buildings as part of the design. This is called a BIPV. For industrial and utility scale power, large solar farms with thousands of panels supplies clean energy to the grid and help reduce fossil fuel consumption. In off-grid and remote areas, solar cells are used to provide power for lighting, water pumps, and telecommunication systems. They're also found in portable electronic devices because of their reliability and low maintenance. In space, solar cells are the main power source for satellites and spacecrafts. They use special high-efficiency cells that can handle radiation and extreme temperatures. Finally, solar cells are finding new uses. They're now being developed for solar-powered vehicles, agrivoltaic systems that combine farming and solar energy, and even wearable devices. In the future, space-based solar power systems might collect sunlight in orbit and transmit energy back to Earth. To conclude, solar cells are a major part of our move toward renewable energy. They convert sunlight directly into electricity, require little maintenance, and help reduce pollution. This ends my part of the presentation about solar cells. Now I'll turn it over to Yasa James Vasquez, who will continue our report and discuss the next topic, solar ponds. Thank you.
So, good day, everyone. I am Mr. James Basket, and I'm here to present to you uh, solar panels. Also, what is a solar panel? A solar panel is a low-cost solar collector designed for a long-term thermal energy storage. The most established type is the salinity gradient solar panel, or the SGSP, which uses a concentration gradient of salt, a halocline, to suppress natural convection and trap solar energy as heat. So SGSPs may contribute significantly to the need for pollution-free energy by providing electricity at a competitive price. So how does it work? So a solar pond works by maintaining three distinct layers of water. So the magic happens in the middle layer, which acts as an insulator. This layering is achieved by carefully controlling the soil concentration or salinity. The saltier the water, the denser it is, so it stays at the bottom. So here is a visual representation of how a solar pond works. So here, the top layer or the epilimion, this is called the upper convective zone or the UCZ, or sometimes also called permixed layer or UML. So makita nato no nga na po yung mga isda-isda dira. So na po surface algae. Next, the topmost layer, characterized by low salt concentration and uniform temperature due to surface mixing. Ano na siya. This is also sometimes termed as freshwater because aning pond kay there is a constant there is a need for constant freshwater. So man na siya sa babaw, like dapat yung magagas ano na dira pa sa babaw. Then makita po nato there is the thermocline. So this is the non-convective zone or the NCZ, and or this is the gradient layer. So this intermediate layer, usually 0.8 to 1.2 meters thick, acts as an insulator, preventing convective heat loss from the bottom layer. Both salinity and temperature gradients increase continuously with depth. An optimal NCZ or non-convective zone thickness of 1 meter is suggested. So, then we have the bottom layer or the hypolimnion layer. So, man siya ang pinaka salty out of all. So, this is also called the lower convective zone or the LCZ, or this is also called storage layer or the SL. So, the bottom layer containing highly concentrated brine, by the way, brine is a high concentration solution of salt in water. Containing highly concentrated brine absorbs and stores heat, allowing temperature to reach 90 to 100 degrees Celsius. An optimal lower convective zone thickness of 0.7 meters is suggested. So why is the heat trapped? So in a normal pond, sunlight heats the bottom water. So this is common, you know. This is also discussed on science classes that the hot water becomes less dense and rises in order to cool itself. So man siya may tabo sa normal pond. So it reaches the surface and releases its heat to the air. Then the pond stays cool. However, it is very different when it comes to solar pond. So sunlight hits the bottom water. So this heat is extremely salty and dense. So man siya di ka kasaka bitaw. So dili bitaw ma-kompleto tong cycle. And that is because of the magic layer as well. It remains heavier than the fresh water above even when hot. So convection is blocked and the heat is trapped. Ano na siya. May mahitabo si solar pond. This is very different from a normal pond. So what are the real world applications? So we have electricity. The trapped heat, which is 70 to 90 degrees, is used to boil an organic fluid. And this vapor drives a turbine in an organic Rankine cycle or ORC engine. Sorry. So this generates electricity 24/7 due to the pond's large thermal storage. So an example of this, which is getting nasa illustration or nasa picture, this is the Biit Ha'arva pond in Israel. So it was the largest of its kind, ang gigamit for electricity purposes. So it generated 1 megawatt, or at least it was liquid. However, it was shut down between 1988 to 1989 because of wala na finance. Then, it is also used for industrial heat. Many industries need low-grade heat below 100 Celsius for processes. Solar panels provide a reliable, low-cost source of hot water. So an example of this is the Bhuj solar pond in Gujarat, India, which supplies 80,000 liters of hot water daily to a dairy plant. Tama na siya. However, it was also shut down because of financial issues as well. So other key uses of this is also used in desalination. The low-cost thermal energy is perfect for water desalination processes. Desalination, sorry, used at the El Paso, Texas pond. The next is the heating and cooling. It can be used for space heating in buildings, heating swimming pools, and warming greenhouse in agriculture. And salt production can be co-located with salt farms using the brine and extracting salt as a valuable byproduct. So let's talk about it differently. So the overall energy efficiency for SGSP thermal applications can range from 10% to 20%. The overall efficiencies reported for Granada Industrial Solar Pond were 5.79% and 8.98% after first and second operational periods respectively. About the efficiency. Now we are on economics. Solar panels are considered simple and inexpensive among solar technologies for energy collection and storage. So the capital cost of is highly influenced by the cost of salt, but FGD or the flue gas desulfurization waste salt may meet cost and availability criteria in the future. Model studies suggest that short payback time for an SGSP system is approximately 2 years. So for stability and monitoring. So in terms of maintenance, the stability of the salinity gradient is critical and must be preserved through frequent maintenance. So it is frequent maintenance due because of the to monitor monitoring. This involves regularly taking samples every 10 centimeters from the bottom to the top to check density, pH, and turbidity. Following turbidity. Turbidity is a measure of cloudiness or haziness of a fluid caused by a particle. Siya. And alerts. So monitoring and density difference between the lower convective zone and the non-convective zone can alert operators to irreversible deterioration of the pond's heat extraction potential. So operational parameters and stability. Actually, nakumanom ninagbasa ko there. Geological influence. So the lower convective zone temperature is higher with sand soil than with clay and silt soil because sand has poor heat conductivity, which minimizes heat loss to the ground. Dry and fine sand is preferred, increasing soil moisture content from, example of this is from 5% to 10%, decreases the LCZ temperature due to the soil thermal conductivity. An optimal water table depth of 5 to 6 meters is suggested to minimize losses. So layer thickness. The greatest LCZ or the lower convective zone temperature is achieved when the non-convective zone is thickest because the benefit of reduced heat loss outweighs the advantage of lower solar gain. A practical minimum of upper convective zone thickness of 0.3 meters is recommended to prevent rain and wind evaporation effects. Sorry. So now, stability and monitoring. The stability of salinity gradient must be preserved through frequent maintenance. So mamani ang ganiya. Stability analysis knows principal component analysis or PCA is a monitoring tool for simultaneous analysis of multiple operational and environmental variables. The monitoring should include taking samples, managing ganiha, turbidity, and garparan. Monitoring the trend of density increased between the lower convective zone and the lower half of the non-convective zone. It's recommended to alert to the reversible deterioration of heat instruction potential. So what are the advantages of disadvantages? So the advantages, okay, it's low cost. It's a low cost collector. It's just a pond, dude. It's just a pond. It's just a line pond. Then huge thermal mass. So maka-function siya sa gabi because of its huge thermal mass. So stores energy for days or weeks. Okay, di man gagawas ang init. So generates power day and night. Ideal for rural and developing areas. But there is also a disadvantages. So it requires a large land area and needs a constant supply of fresh water. Also low thermodynamic efficiency for electricity, around 2%. Tragid no tong na-shutdown tong beta arba bitaw. Then salt, I mean mo to siya like reason why aside sa low budget, salt crystals must be managed. So mato pod ganiya nga need i-check or i-monitor ang yang stability og yang mga turbidity, pH, and so mato. So that's all for our report for solar cells and solar panels. We hope that you learned something in this video and have a good day.